Thank you. So hello everyone. I come from Riverside, and thanks for your patience. And I will try my best to avoid some complex calculations and some detailed things. So let's just look at the ultramassive galaxies at redshift about 3 from magazine surveys. So the first question is, what's ultramassive galaxies? So we defined them as the galaxy with log stellar mass larger than 11. And they are generally discovered by deep near-infrared photometry surveys. So if we're looking at these figures, here the solid lines and dashed lines shows the predicted number densities of galaxies, and here those points shows the observations. So at redshift larger than 3, we find that there is a really huge discrepancy at high mass end. So here we have some questions about this range. So are these observations are really massive at high mass end, or they are just some errors from ACD fittings from photometries? So that requires the spectral follow-up, and that's what our group did. So here, I will show you the magazine surveys. So this survey aimed to obtain spectral redshift and determine stellar mass, and we also determine their star formation activities. We set up some target selections to make sure we can observe those faint, distant galaxies. And we use Keck fire. We mainly focus on the K band and H band. So after observed almost I think 4 years, we have collected 20 ultramassive galaxies, and this number continues to grow because my group member are preparing for the observation tonight. So unfortunately, they couldn't attend Keck Science Meeting this year. So maybe tomorrow, I know here we got another ultramassive galaxies. Oh, sorry. So if we look at these UVG diagrams, we find it shows the sample of our surveys. It has a related spans galaxies contains both maybe potential quiescent galaxies and star formation galaxies. But we still have some questions about our magazine survey. So that's, we're not sure whether these galaxies are truly quiescent at such high redshift. And also we find that our photometry only covers from optical to near-infrared band. So that's not enough to cover the dust emission or far-infrared photometries. And if they are truly quiescent, so we don't know the quenching mechanism within that. So here we want to do the follow-up things. We want to construct a comprehensive ACDs, and we want to know the gas content within these ultramassive galaxies. And we also want to talk about a little about agent component. Thanks for Justin. I don't have to do some introduction about agent feedback. Okay, so first thing, we have to construct a comprehensive ACDs. Here on the left is our original photometry, only from U-band to MIPS 24 micrometers. So that's not enough, and we include 2 more far-infrared catalogs. So one is from ALVA, and another one covers the band from 100 micrometers to radio wavelengths. And fortunately, we could find 2 ultramassive galaxies in our surveys that could be identified in those 2 far-infrared catalogs. So we could find here one I showed as blue one. It is in the quiescent wedge of UVG diagram, and another one It is located in the upper right region. So this is a really dusty one. And here I also show the case image and also the emulsifier spectra for these two galaxies. Okay, so now we want to figure out, now we have spectra and we got far infrared data. So we want to know whether these two things could affect the estimation for stellar mass, for stellar properties of our ultramassive galaxies. So we do such a thing. First, we analyze the properties only from the optical to near infrared photometries. We only choose the photometry redshift and fitted by fast code. And then with the Keck spectra, we can refit again with the spectral redshift, and we expand the SED from with the ALMA and Herschel, and we expand to radio wavelengths. We refit it with a new package called SIGAL. So we do the 3 different SED fittings, and we can compare the results. So first one, I want to show the result for these blue galaxies. So here I want to highlight that the Keck spectra verify this galaxy is really at high redshift, with the redshift about 3.2. So that's great. We have found one ultramassive galaxy at redshift larger than 3. And here I show the properties from 3 different SED methods shown in the star formation rate versus the stellar mass diagram. And we can focus on this red region. That means the 3 different SED fittings shows consistency, and all the, sorry, it's really, and all the values confirms their stellar mass larger than 11. So that's great. We have found one. However, it's not, although it is in the quiescent wedge, but it's not a truly quiescent galaxy, since it still has some moderate star formation rate. So we can guess maybe it is in the quenching process. So it might be a younger quiescent galaxies. So with a little analysis about the quenching mechanism in these galaxies, we find there is the obvious O3 features and H-beta emission lines from the Keck spectrum. And also we find that here is the SED fitting for this galaxy. It shows the significant mid-infrared detections. So here I haven't labeled here. So that indicates the agent activities within these galaxies. And such agent feedback might accelerate the quenching process of this galaxy. So next, we can show the result for another one, the red one. So here is really different things. The Keck emulsifier confirms this galaxy is not at redshift larger than 3, but at redshift about 2.5. So, another thing is it is a really dusty one. So we see the result at this star formation rate and stellar mass diagram. We find that here the shallow one is the initial fitting result. At first, we guess it might be a quiescent galaxies, but with the Keck spectra, we constrained its star formation rate and the stellar mass, and also after include far infrared data, we can estimate more accurate star formation rate. So now it is really higher, the star formation rate. It's not a quiescent galaxy, but it is indeed a dusty star-forming galaxies. So that's why we want to include Keck spectra and far infrared data in our analysis. We want to exclude such a situation about ultramassive galaxies. Yes, its stellar mass is still larger than 11. So So this is our important findings in the research. And so now we got a comprehensive ACEDs and spectra. What else can we do? So we think about we should do something about molecular gas mass estimation, molecular gas mass. So here is the things I list how to do the estimations. So I just list here. If you have any questions, just feel free to talk to me after the talk. And I will directly show the result. So here we find the molecular gas mass and in the two different populations because they have different redshift. For blue one, it is obvious. We show them the Y X-rays is molecular gas mass, and here the X-ray is stellar mass. So it is located in the moderate of such population at the similar redshift range. So that's great. It's not, so it still has some gas content within these galaxies. But for another one, it's not surprising to see such a galaxy at the top of this population because it is really dusty. So the dust mass, of course, the dust mass will indicate it has a rich gas reservoir. So finally, we could do, at the end, we want to do some prediction about these two ultramassive galaxies. We want to predict when they will stop star forming and what's their final stellar mass. So this figure can answer those questions. And on the y-axis, we show the stellar mass, and we show their redshift, and we show the age of the universe. So for two galaxies, we assume their star formation rate keep constant within 1/2 depletion timescale. So we calculate depletion timescale here. So it represents how long this galaxy could consume their gas reservoir. So I draw a figure like this triangle. So we can show the trends for these two galaxies. For the dusty one, it has the higher stellar mass and longer time scale. And we calculate it might start forming at redshift about 2. And we also list some other, these other points from some other reference that they have confirmed quiescent galaxies. So they could be potential descendants of our two ultramassive galaxies. Okay, so now I can do a brief summary about my project. At first, we use ultraviolet to near-infrared photometry to find two galaxies, which is blue one and red one. So, and with Keck fire, and also we constrain their stellar mass and star formation rate. And also with far-infrared data, we find one galaxy potential in the quenching phase. It's not a quiescent one. And another one, it is really a dusty star-forming galaxy. It's not a quiescent one. And the blue one it might have some agent activities within these galaxies. And we also estimate their molecular gas mass. And finally, we predict their mass evolutions, and we calculate their final stellar mass and redshift. So that's my research, and thanks for your patience. And